model is we would draw all the layers of the earth, right? So can somebody tell me what are the layers of the earth?
Core, mantle, crust.
Good, so let's draw that in there. Core, where is that in my picture?
Middle.
All right, so I'll draw the core, okay? And then we have mantle that goes all the way to here. And then on top of the mantle is the plates, which is the crust, right? And in fact, we call this part here, we even call this like the moho, which is like partly mantle, partly crust, all right? So we also have that layer, so here's the mantle, okay? Now, as somebody also just said, right, we have the magma that's coming up. Let's draw the magma coming up here. So what's going to show up on Earth? What's going to be right here when this magma is coming up? If it's coming up, what do we call that? Where the magma comes out of the Earth? What do we call it? What's that? A volcano, right? So we have a volcano. Let's draw a little volcano happening right here, okay? And we'll show the magma coming up through this crack that's getting formed as the two plates are getting pushed apart. And we'll show like the eruption happening. What do we know happens to that magma? What do we call magma when it comes out of the ground?
Lava.
It becomes lava. And then what happens to it very quickly?
Into rock.
It turns into rock crystals, right? So those rock crystals fall along the side of the volcano and it starts to build up. We start to build new plate, right? We're building new plate. So it depends on what type of magma is coming up, right? Now, what causes the magma to come up? Why is magma coming up? Why is magma coming up? What explains why is the magma coming up? So one, it's less dense. So we see that like as it's rising because if we were to zoom in there, the particles of rock are moving a little bit further away from each other because they're less dense. Why are they less dense? Less dense, liquidy rock is rising to the surface. Okay? Look at all these fancy words we're getting in. Density, right? We're getting magma, right? We're getting velocity, right? We're getting the names of the parts. We're getting names of different types of rock, right? This model is quickly becoming really, really rich in terms of what it's showing us. But let's talk about this. Let's talk about these atoms or particles. Why do these particles move farther and farther away from each other? Why are they getting less dense? Yeah, because they're getting hotter. Why did they get hot? Why does this rock get hot in here? What makes it hot? Remember? Yeah. So then I can draw a little zoom in circle to talk about what is causing the particles to release energy. Now I can start talking about, and what is radioactive decay? Somebody build off, Jessica's on fire today. Somebody build off of that. What is radioactive decay? Close. Not the atom itself. It's a part of the atom. The nucleus. So what we would have to do is we would have to draw like the nucleus of an atom in here, right? Very good. And we would have to show like the nucleus of the atom, and then there's electrons that are around, right? So we can name the nucleus, right? And the nucleus breaks apart, okay? And when it breaks apart, what happens? We call that radioactive decay, but what happens when we have radioactivity? Right? When that, Sebastian, put the phone away. Nicholas, put the phone away, right? Right? Your family told me to take it, and we already talked about I don't want to take it, so put it away, be responsible. Right? So why does radioactivity make things hot? Why does radioactivity make things hot? What is hot? Like, what's the difference between hot air and cold air? Like, when you look at a hot air that's above the road, of like on asphalt, when you go out there and it's a hot day and you see the air, what do you notice about the air molecules on a hot day? You can actually see it above a road surface, or looking at the field on a hot day before graduation. Go out there this year when graduation, look on the surface of the field. What are you going to see? Shimmering. Why? Because those molecules and particles are moving and banging into each other and pushing on each other, right? And it creates a high pressure because they're pushing away from each other. And that's why these become less dense. Because what is temperature? Temperature is nothing more than the measurement of how fast those particles are moving, right? If the particles are moving slowly, the temperature is low. If the particles are moving fast, that means we measure them and we say they're moving fast. Let's give them a temperature of 200 degrees Celsius, because that's how fast they're moving, right? So we know, so let's talk about this. Why does radioactivity cause things to get hotter? Like, my drawing is really, really poor because I might have to do it again better. But in your notebooks, you drew an atom and you drew, like, when radioactive decay, as Fabi said, a proton is leaving. It's moving away, right? When it moves away, is it going to hit something else? Yeah. And when it bangs into something else, it's going to cause that to move. And what did we just say was temperature? How fast things are moving, right? So if you have decay happening, that's going to cause things to move in the crust more. That's going to add energy, right? So we don't have a lot of time to continue this on because class is ending. But what I want to just say is, everything you built, I didn't tell you what to build. All of this came from what you told me to write up here. Could I add more? Absolutely. We only worked on this for 12 minutes. But take a picture of it. Make sure that this is in your notebook. And then you need to add more. Like, I didn't finish this. This is unfinished. Okay? This is unfinished. All right? The convection here is unfinished. We didn't finish this model. Right? So how much more time do you want to spend working on this model before Monday? And that's what your plan is as we continue this lesson and we continue thinking about what's happening in the earth. If you borrowed a Chromebook, I'd like you to put it back in the right cubby, right? So make sure, like, that Chromebook gets in cubby number 2, right? That one gets in cubby number